is breaking news, and it's about stars.
This is a Hertzsprung diagram, by the way.
What is a Hertzsprung gap, and why did they name the gap?
I know this one. Okay, so the Hertzsprung is a cluster of stars named after N.J.R. Hertzsprung, who was the first person to notice the absence of stars. He is the first scientist, actually, because they named the gap after him because he was the first scientist to see that there weren't any stars there. Real genius, if you ask me.
No one asked you.
What does a spectral class mean? Why are there letters instead of numbers on the x-axis?
Oh, I know this one. Spectral class means that in a group of stars are classified according to spectrum, especially using the Harvard classification. The letters have the advantage of being more linear than temperatures.
Why are they categorized in groups? What does color have to do with the stars?
The stars are given letters based on the hotness and sometimes the color of the stars. Very hot stars were given a B. These stars are bluish white color. A little less hot were given A. A little less hot were given F. This group is a yellowish group of stars, and so on. A group of boys at Harvard adopted a sequence that runs from hottest to coolest like this: B, A, F, G, K, N. Astronomy students have been taught to remember this sequence as the memory. B, fine girl, kiss me.
So there's a line of stars in the Hertzsprung-Russell diagram called the main sequence. And there are about 90% of the stars in our solar system that live on the Hertzsprung-Russell diagram. The stars are in a line because the main sequences account for about 80 or 90% of the total stellar population.
So I see the sun in the Hertzsprung-Russell diagram. The sun is on the diagram. Are the planets there as well?
Well, planets aren't actually on the diagram because they're not stars, but the sun is a star, but the planets aren't. So they're not going to be on the diagram because they're not stars, because this is a star diagram.
So what exactly is the sun dwarf?
These are created when a red giant loses its outer hydrogen layer before the core fuses helium.
So what's the difference between a white dwarf and a red dwarf then?
Right?
Well, the red dwarf and the red dwarf are variable mass, no more than 40% of mass from the sun, while the white dwarfs have about the same amount of matter as the sun packed into a star-sized bird.
Okay, what is a supergiant then?
Okay, so a supergiant star is a very large star that is even better than a giant, often despite it being relatively cool. A giant is a star that is big and bright, but not as big and bright as a supergiant star.
So how long is the lifespan of the star exactly?
Well, the life of a star depends only on how much mass the star has. Stars that are 10 times the size of the mass of the sun will last about 100 million years. Stars with about the sun's mass will last 13 billion years. So that's how long the sun is going to last. It's 13 billion years. And stars with 1/10 the mass will last 100 billion years or longer.
So what exactly are the changes a star goes through in its lifetime?
The first is a nebula, which is a cloud of dust and gas that comes from planets and stars. The second is a star, which is a cloud of gas that's fused into white energy. The third is a red giant, which is a brighter star that is cooled. Next is a red dwarf, which is a small cold star, and then a white dwarf, which is a small hot star. Then a supernova type 1, which is what a star, small hot star. There's a supernova type 1, which is a star that falls into a white dwarf causing an explosion. Then there's a supernova type 2, which is when stars 10 times the size of the sun fall, causing explosions. And there's the neutron stars, which are mainly made up of neutrons, which are produced when the supernova explodes, forcing protons and electrons to combine and to produce a neutron star.
You can't forget the black holes. Black holes are believed to form from massive stars at the end of their lifetimes. The gravitational pull on a black hole is so great that nothing can escape from it, not even light.
Thank you all for tuning in to Scientific Channel 101. Have a splendid day.
Peace out, Scouts! I want to do the same homework